This video is on identifying conic sections. A conic section is the two-dimensional shape or cross-section that results when a plane intersects a double cone. A double cone being two cones that are joined by their vertices, or the two pointy parts. If the plane that intersects the cones is parallel to the bases of the cones, then the cross-section is a circle. If the plane is not parallel to the bases and does not intersect the base of one of the cones, then the shape of the cross-section is an ellipse or an oval. If the plane is not parallel to the bases and does intersect the base of one of the cones, the cross-section is a parabola, which you've seen in quadratic functions. If the plane is perpendicular to the bases of the cone and intersects both of the cones, then the cross-section is called a hyperbola. And here's a picture of what those look like. So the first one, for a circle, the plane that's intersecting the cone is parallel to the base of one of the cones. An ellipse, or the oval shape, notice the plane is not parallel to a base and it does not intersect the base. For a parabola, the plane again is not parallel to a base, but it does intersect one of the bases and gives you this quadratic shaped curve. And for a hyperbola, the plane is perpendicular to a base, intersects the cone in two places, and creates two curves. The equation of each conic section can be written in either standard form or in general form. The general form of the equation of a conic section is ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. Now the coefficients of the x squared term and the y squared term determine which particular conic it is. So if a and c are equal to each other, then the conic is a circle. If a and c have the same sign, so in other words, if they're both positive or both negative, and a is not equal to c, then the conic is an ellipse. If a is equal to 0, or c is equal to 0, but not both equal to 0, then the conic is a parabola. In other words, there's only going to be one squared variable. And if a and c have opposite signs, so a is positive and c is negative, or a is negative and c is positive, then the conic is a hyperbola. So that's general form. And then for each of these conics, sorry about that, you can also write them in standard form, and here's standard form of each conic. And you can tell that from the equation of a circle, this should be familiar to you from geometry. You'll notice that there's going to be an x squared term and a y squared term, and there really isn't the coefficient of x and y is going to be 1. For an ellipse, you'll notice there's going to be an x squared term and a y squared term and a plus in between. So that's going to make the coefficient of x squared positive and the coefficient of y squared positive. You'll notice that there's actually for the rest of these, there's two different ways of writing it. So an ellipse can either be, all of these shapes can either be more horizontal or longer in the x direction, or they can be more vertical, longer in the y direction. A parabola, you'll notice both of these have only one squared term. In this first one, x is going to be squared, and this one, y is going to be squared. And a hyperbola, the formula for a hyperbola is very similar to that of an ellipse, but you're going to have a minus between the two fractions here, and that's going to give you a and c being opposite signs. So at this point, don't worry about memorizing these formulas. These formulas in particular, and also general form, will come up as you work through the unit applications. And before you do the last unit application in this topic, I'm going to ask you to come back and rewatch this video, and actually this will make a little more sense after you've worked through a good bit of this topic.